Hello everyone. Today's topic is surface integration. This topic is from vector integration. First definition and formula for the surface integration is, let f bar is a vector that will write as f bar is equal to f1 I bar plus f2 j bar plus f3 k bar, where f1, f2, f3 are continuous and differentiable functions of x, y, z. And formula for the surface integration is integral f bar dot n bar ds is equal to double integral over s f1 dy dz plus f2 dz dx plus f3 dx dy. Here surface integration find by using the double integration, because of the surface integration is depending on the projections. So projections on two planes only, so that's why we can use the second order means double integration. And n bar dot ds bar or n bar dot ds is equal to I bar dy dz plus j bar dx dz plus k bar dx dy. If you multiply f bar n bar ds, then we can get I bar dot I bar is 1 f1 dy dz plus j bar dot j bar is 1 f2 dz dx plus k bar dot k bar is 1 f3 dx dy. And here n bar is a outward drawn normal to the surface and ds is a small part of the surface. So in this example, the surface is square shape. If you take small part from the surface, that is called ds, and outward drawn normal is n. If the surface is curved surface, you can take a small part from the middle of the surface, then that is ds, and the outward drawn normal is n bar, and the vector is go through this ds, then that is f bar, and n bar and f bar make angle, that is theta, and it is separately we can explain it with the ds, that is this square part is a ds from this curved shape surface. Then from this surface, n is a outward drawn normal and f is a vector, and these two make angle theta. So the surface integration is explained with projections. That projections are also three types of projections are there. One is projection on xy plane, one is projection on yz plane, and projection on zx plane. First one is, let R1 be the projection of S on xy plane. For example, if you take the surface, curved surface S, and take the small part from this surface, this is called ds. So this ds projecting on xy plane. So projection is like this. And formula for the projection on xy plane to the surface integration is integral over s f bar dot n bar ds is equal to double integral over r1, because of projection on r1. So that's why we can write here r1 f bar dot n bar dx dy by modulus of n bar dot k bar. Here projection on xy plane, so that's why we can write here dx dy by modulus of n bar dot k bar. N bar is a normal to the surface and k bar is a normal to the axis. So here normal is parallel to the z-axis, so that's why z-axis normal is k bar, so that's why we can unit normal is k bar, so that's why we can write n bar dot k bar. Next, projection on yz plane. Let R2 be the projection of S on yz plane. For example, this is a given surface and it is in xy plane. Projection on yz plane, this is a projection of S. This part is a projection of S, but it is in yz plane. So formula for the projection on yz plane surface integration is integral s f bar dot n bar ds is equal to double integral over r2 f bar dot n bar projection on yz plane, so that's why dy dz by modulus of n bar dot I bar. Here the projection, if you take a small part ds from this surface, then projection on yz plane and outward drawn normal is parallel to the x-axis, so that's why we can take dot I bar. And next one is projection on zx plane. If let R3 be the projection of S on zx plane, if you consider a plane in xy, means curved shape plane in xy quadrant, if you take small part ds, this projection on xz plane, then the formula for the projection on xz plane is integral over s f bar dot n bar ds is equal to double integral over r3 f bar dot n bar projection of xz plane. So that's why dx dz by modulus of n bar dot j bar. If you take a outward drawn normal from this, so that normal is parallel to the y-axis, so that's why y-axis normal is j, so that's why we can write here n bar dot j bar modulus of. And going to the example, evaluate integral s f bar dot n bar ds, where f bar is equal to 18z I bar minus 12j bar plus 3y k bar, and s is the part of the surface of the plane 2x plus 3y plus 6z is equal to 12 located in the first octant. So here the given plane is phi is equal to 2x plus 3y plus 6z minus 12 equal to 0. So normal to the plane, how to find the normal to the plane? We have a formula, that is del phi, means gradient of phi is a normal to the given plane. So that's why first find del phi. Del phi equal to I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So del phi is equal to I bar dou phi by dou x. With respect to x, derivative to the phi is 2. Because of y, z are constants, so that's why derivatives are zeros, and 12 is also constant 0. Next, going to dou phi by dou y. With respect to y, derivative to the phi is 3. Only 3, because of x, z are considered as constant, because of it is a partial derivative, and value is 3. Then j bar into 3 plus dou phi by dou z is 6. X, y are constants here. 6z derivative is 6 into z derivative 1. So that's why 6. We get 2i bar plus 3j bar plus 6k bar. And unit normal n bar is equal to, formula is del phi by length of the del phi or modulus of del phi, that is 2i bar plus 3j bar plus 6k bar by length is found by using under root of x square plus y square plus z square. X value is 2, y value 3 and z value 6. So that's why we write under root of 2 square plus 3 square plus 6 square. Then we can get 2i bar plus 3j bar plus 6k bar by root 49, that value is 7. So that's why 1 by 7 into 2i bar plus 3j bar plus 6k bar is a unit normal to the given surface. So first, going to the surface, this is our given surface. This triangle shape is a given surface to that, and given surface is for part of the surface in the first octant. So that's why we consider this triangle part. How to get these points on y-axis? Z and 0, z is 0 and x is 0. Substitute in the plane. We can get, if on first, for example, first you have to take on x-axis yz 0, 2x is equal to 6. Means 2x is equal to 12, x is equal to 6. Means the point is 6, 0, 0. And on y-axis xz 0. Means here 3y equal to 12, y is equal to 4, 0, 4, 0 on y-axis. Next z-axis x, y, 0. So that's why 6z is equal to 12z is equal to 2. So 0, 0, 2 is a point on z-axis. So first you have to take the points and draw the plane. So we have to consider only first part of the, means first quadrant part of the plane. So that is our surface. This triangle shape is a given surface, and from this surface we can take the small part ds, that projection on xy plane. So that's why let R be the projection of s on xy plane. So write the formula for on xy plane is integral over s f bar dot n bar ds is equal to double integral over r f bar dot n bar dx dy by modulus of n bar dot k bar. First you have to find f bar dot n bar and n bar dot k bar and substitute in this formula. First, f bar dot n bar equal to 18z I bar minus 12j bar plus 3y k bar into n bar is 1 by 7 into 2i bar plus 3j bar plus 6k bar, and 1 by 7 is constant, multiply I bar dot I bar is 1 and 2 into 18z 36z minus 12 into 3 minus 36 j bar dot j bar is 1, 3y into 6 18y k bar dot k bar is 1. So now write here from these three terms 6 common, so 6 by 7 into 6z plus 3y, first write all positive values, plus 3y minus 6. So next going to the n bar dot k bar is equal to 1 by 7 n bar value, first write 1 by 7 into 2i bar plus 3j bar plus 6k bar into k bar value here into multiply with k bar, then the value is 6 by 7. Because of k bar dot k bar is 1, we can multiply only these terms because of I bar dot k bar 0, j bar dot k bar 0, so that's why we get only 6 by 7. Then substitute all the values in the integration, we get double integral over r. So f bar dot n bar value is 6 by 7 into 6z plus 3y minus 6 into dx dy by modulus of n bar dot k bar. So n bar dot k bar is 6 by 7. If you apply the mod, then it is a positive value, so that's why we get only positive 6 by 7. So 6 by 7, 6 by 7 cancel. Then the integration with xy, so dx dy, so that's why here you can substitute the z value from the given plane and also find the limits to x and y. First, from the given value, find the z value, that is 2x plus 3y plus 6z is equal to 12. 6z is equal to 12 minus 2x minus 3y. Z is equal to 1 by 6 into 12 minus 2x minus 3y. Going to the plane, here the plane is xy, so that's why on the xy plane z is 0. So our plane becomes 2x plus 3y is equal to 12. That is 3y is equal to 12 minus 2x, y is equal to 1 by 3 into 12 minus 2x. So next one is on x-axis y0. So that's why 2x is equal to 12, x is equal to 12 by 2, it is equal to 6. Now going to the limits, x limits are 0 to 6. Why we consider the lower limits are zeros? Because of the projection in xy plane. So xy plane, the limits are start from 0 in the x plane, so that's why 0 to 6, and y also same, the projection on xy plane, so y is also start from 0 to 1 by 3 into 12 minus 2x. So we are taking the surface in one part, so means that first octant, then projection is also in one octant, so that in one octant always the lower limits are zeros, so that's why we can take x limits are 0 to 6, y limits also 0 to 1 by 3 into 12 minus 2x. So now going to the integration, integral s f bar dot n bar ds, x is 0 to 6, y is 0 to 1 by 3 into 12 minus 2x, and substitute the z value, 6 into z value is 1 by 6 into 12 minus 2x minus 3y plus 3y minus 6 dx dy. That is, you can cancel here 6 and 6, and 12 minus 2x minus 3y plus 3y minus 6 plus 3y minus 3y cancel, and simplify it, we get 6 minus 2x dx dy. So from 6 minus 2x common 2, right outside we get 3 minus x dx dy. Next integrate with respect to y. Here no y terms are there, only integral dy. That's why y is the integral dy is y, limits are 0 to 1 by 3 into 12 minus 2x. So integral dy is y, limits are 0 to 1 by 3 into 12 minus 2x. And substitute the upper limit and lower limit. Lower limit is 0. Obviously you can substitute only upper limit, that is 2 into integral x is equal to 0 to 6, 1 by 3. So we are substituting y value here, 1 by 3, 12 minus 2x into 3 minus x dx. So here 1 by 3 is constant right outside, and also 12 minus 2x 2 common, that is also right outside. 2 into 2 by 3, integral x is equal to 0 to 6, 6 minus x into 3 minus x dx. You can multiply these two factors, we get 18 minus 9x plus x square into dx. Then 4 by 3, 18 is a constant, integral dx is x, 18x minus 9 is a constant, x integration is x square by 2 plus x square integration is x cube by 3, limits are 0 to 6. So now substitute the limits, we get 4 by 3 into 18 into 6 minus 9 into 6 square by 2 plus 6 cube by 3. We get 18 into 6, 108 minus, here we get a 162 plus here we get 72. Then simplify it, we get 4 by 3 into 18, then the answer is 24. That's all for today.